Hi, welcome to our last example for 6.3, Pascal's triangle and expanding binomial powers. In this example, that's exactly what we're going to do. We're going to expand a power of a binomial. So if you remember, I brought that up in the first video, and this is one of the more useful applications of Pascal's triangle. So let's go ahead and start this first one. So our first binomial is a plus b to the exponent 7. So if we were to do this the old-fashioned way, we would have to write out a plus b. We'd have to write this out 7 times, and we would be doing FOIL with each one. And as soon as we calculate this one, we would get 3 terms, and we would have to expand it into the next one. And it would just be a giant disaster. So the nice thing is Pascal's triangle really saves us a lot of time with this. So if you remember the triangle, some of the first elements, they look like such. So what these elements will refer to in a row is they'll actually end up being the coefficients. So on this expanded binomial. So once this is all said and done, we're going to have a bunch of coefficients, and whatever exponent it is, we need to go to that row number, and we need to grab all these elements that are inside there, and they will play a part in our coefficient that we will have. So this one here, if I had to answer this one, I would first begin by locating row 7. So we're going to locate row 7. So right now I just have, this is row 0, row 1, 2, 3. I need to go all the way to row 7. So that's going to look like 1, 4, 6, 4, 1. And I suggest maybe you write one of these out and kind of keep it off to the side. That way you don't need to keep doing it every time. Also 35 there. So this is going to be 4, 5, 6, row 7. So we need to take these elements here, and those are going to play a role into the coefficients. So we will grab each one. So we'll write out 1, 7, 21, 35, 35, 26, 7, and 1. I leave myself a little bit of space in between here. Okay. And then right underneath this, I take whatever my first term is in the binomial. So my first term in the binomial is a. So I'm going to write that out down underneath in here. And I just write it out underneath every number. Okay. And next thing I have to do is I have to place exponents on these. Okay. So the exponents for these, they're going to start off with the same value as the row number. So they're going to start off at 7, and then they're going to go down each time. Okay, then underneath that, I'm going to grab my second term in the binomial. So whatever that value is. So for this example, it's just b. But in other examples, I'll take whatever is actually written and I'll put that in. So maybe it could be this, like negative y squared. So whatever is here, I take the coefficient and everything, and I'm just going to write it down underneath. So we'll have b to the set. We don't start at the 7 though. Oops. We this time we go the opposite way. We start at 0 and then we work our way up. Now, you might be wondering, okay, like what's going on here? Like why are we doing all this? So, believe it or not, this is actually a shortcut. I know it's a little bit lengthy still, but when we take these, all three of these here, we multiply them together, it's going to give us the first term of the expansion. Um, so the next thing I do is I just multiply straight down. So we're going to take everything that's written there and we're going to multiply straight down. So 1 times a to the 7 times b to the 0. So b to the 0 is just 1. So I have 1 times a to the 7 times 1. I get just a to the 7. That's my first term in this expansion. Okay, then I go to the next one. So 7 times a to the 6 times b to the 1. That's going to be 7a6. The pen's acting a little bit funny here. 7a6 times b. I don't need to write the 1, right? B to the 1 is just b. Notice I also put a plus sign in here. I did that because these are all positive. And when I multiply through, I get a positive value. Okay, just keep repeating. 21 times a to the 5 times b squared. And then the next one, 35 a to the 4 b cubed. And then the next one, 35 a cubed b to the 4. And the next one is 26 a squared b to the 5. And then we have 7 times a times b to the 6. And then we have 1 times a to the 0, which is, sorry, that's actually just 1. 1 times b to the 7. So we're going to get 1b7. So just write b7. So this here is my answer to this. So I know this is actually a pretty hefty first example to the exponent 7. So when we do any quizzes or tests, probably not going to go any higher than 4 as the exponent. That means we'll be going to row 4. So you'll have 5 terms. Okay, we always end up with one extra term than the exponent. So this one was raised to exponent 7, and notice we have 8 terms, 4 and 4. The great thing about this is already simplified. I can't add any of these together because there's no like terms in the statement. This is fully simplified and our final answer. Okay, so we're going to try one more. We're going to make an adjustment. So we'll do part B next, but I'm going to change the exponent. I don't like the 5 here. I want to make this a little bit more meaningful. So we're going to change this to a 3. Okay, let's go ahead and start that one. That's m minus n cubed. So I'm actually going to do this kind of like our older way of doing it. So we're going to do FOIL. So I'm going to have to expand out all the brackets. And then we'll go ahead and do Pascal's triangle. That way we really get a feel for how it works. I couldn't do that with this one just because it's so large, the exponent. It probably would have took about maybe an hour and a half, and there probably would have been mistakes at the end, and I wouldn't have ended up with this answer. So it shows you how helpful these binomial expansions are. So let's start the FOIL process. We'll do those there. So we'll have m times n, we get m squared. M times negative n is minus mn. Then we'll do these two. So we'll have negative n times m, that's going to be minus mn. Negative n times negative n, positive n squared. Okay, we have all of that times n minus n. Nice thing is I do have like terms there, so this can be cleaned up to m squared minus 2mn, because we have negative mn minus mn, that's minus 2mn, plus n squared times n minus n. Okay, now we got to distribute again. So the first one goes into both. M squared times m is m cubed. M squared times negative n is minus m squared n. Okay, then the next, we're going to have this term times n, then times negative n. So we'll have minus 2, m times m is m squared, then n. And then we have minus 2 times minus 1, that's going to be plus 2. M, and then n times n is n squared. And now our last two, I'm just going to change colors for this one. We'll have n squared times n times m, and then times negative n. So then we'd have plus m n squared minus n cubed. Okay, we may or may not be able to collect some like terms. It looks like there's a couple here. So we got these two. Those are like terms. So minus m squared n minus 2m squared n. I'm going to have minus 3m squared n. Okay, so that kind of takes care of those. And then I got these two. So 2mn squared plus mn squared is going to be 3mn squared. So that's fully simplified. Now I like to compare this to what I would get if I would do Pascal's triangle binomial expansion. So I'm hoping to get the same answer. So step one, locate row number. Okay, for us, it's going to be the third row because it's the third exponent. Okay, third row are these ones right here. 1, 3, 3, 1. So 1, 3, 3, 1. Okay, step two, write out first term. Okay, the first term in the binomial, for us it's n, so we're just going to write that out. Okay, so you write out the first term, and then the exponents descend. Okay, it just wrote descend there. So they're going to start off at 3 and then go down. If you want, you can always cross this out and make it a 1. Anything to the exponent 0 is 1. Okay, step 3, write out last term. And then we'll say exponents ascend. So they go up. So the second term here is actually negative. It's a negative n. That's what we're going to write out. We're going to put it in a bracket. And our exponents start from 0 and they go up to 3. Okay. The exponents always need to be equal to the row number or equal to the exponent on the binomial. All right. Last step, multiply down. Okay, multiply downwards, straight down. So that's going to be 1 times m cubed. This is also 1. Anything exponent 0 is 1. So we're just going to get m cubed. I'm going to put an equal sign here because this is going to be our answer. Then the next one, 3 times m squared times negative n to the 1. Well, that's just going to be negative n. So I'm going to actually have negative 3 m squared n. So multiply the coefficients first. Okay. So 3 times negative 1, and then the m squared times the n. Let's do it again for this one. So when we have a negative n squared, that means my coefficient is going to actually become positive, right? This is actually equal to a positive n squared. So I'm going to have 3 times m times n squared. So I'm going to have 3m n squared. And the last one, 1 times 1. This negative n cubed, that's actually going to work out to negative n cubed. Because it's a negative times a negative times a negative. Okay. So we have 1 times negative n cubed. That's just going to be minus n cubed. Okay. Does that look like our final answer? Yeah, we got 3m, or m cubed, I mean, minus 3m squared plus 3m squared. That's my bad looking 3 here. That's a cube. You can see it up here. And then we got that one right here. So yeah, our answers are identical. Okay, so you can see how this is like a shortcut to doing the expansion. So not much of a shortcut for like this one here because it was only degree 3, but imagine trying to do it for this one. So definitely makes things quicker in the long run. I'm actually going to end this video a little bit short. I'll post one more video showing the examples for the next two. Hope it's been helpful. I'll see you in a bit.